Good morning. My name is Brian Soliday, and I manage sales in the Rocky Mountain region for One Spatial, and I'm based here in Frederick, Colorado. I'm joined today by Kevin Sigwart. Kevin is One Spatial's Chief Operating Officer, and Kevin is based in our U.S. headquarters office in Vienna, Virginia. I want to thank everyone for joining us to talk about challenges with geospatial data. We'd also like to thank GISCO and YGO for organizing the summer series here in Elevation Geospatial, and happy that we were able to sponsor this virtual conference event. You know, I'm sure we would all rather be doing this in Steamboat or Sheridan, but hopefully next year we'll all be together face to face. This morning we'd like to focus on some work we've been doing with a variety of transportation-focused organizations. We're helping them navigate how they handle the constant changes to the data coming in from the various sources and dealing with requirements on that data, improving those management processes. For those of you who aren't familiar with us, One Spatial Inc. is a US company that's wholly owned subsidiary of One Spatial Group out of Cambridge in the UK. The organization began its life over 50 years ago at Cambridge Labs at Cambridge University, and Cambridge still serves as our organization's worldwide HQ. Our US headquarters, as I mentioned, is located in Vienna, Virginia, but we have satellite offices in California, Colorado, Texas, Georgia, and Pennsylvania. Additionally, as you can see on the map, there are One Spatial offices around the world. They're all providing local support and technology implementation for our growing global customer list. We have significant experience across a number of industries, including federal, state, and local government, transportation and infrastructure, utilities, primarily electrical distribution and water, and facility management. One of the keys to the success is a solid technology partnering approach. The One Spatial team on a global level has significant experience in ancillary technologies that are key to our joint success. And at the core, One Spatial focuses on data management solutions to improve the data quality of large, complex systems. We use validation, integration, automation, and our rules-based approach to build strong data infrastructures, leading to better outcomes and making your data smarter. So One Spatial started doing work in the US about 7 years ago with our first customer, the US Census Bureau. Since then, we've expanded to nearly 50 clients in all of our key segments that I previously had mentioned. Some of the projects with these customers are supporting them with our rules-based approach to conflate, validate, and integrate their data. And this data could be focused on addresses, next-gen 911, transportation data, which we're going to focus on today, utilities, as well as spatial data infrastructure projects. As you can see, we have a number of different state DOTs as customers, including California, Arizona, Kansas, Alabama, Rhode Island, Massachusetts, Pennsylvania, West Virginia. So a pretty solid list of DOTs. We also work at the federal level with Federal Highways Administration, FHWA, to do a number of activities such as data validation, change detection, and conflation for the performance monitoring, for the highway performance monitoring system, or what's known as HPMS. As we are both as we're data agnostic, we're also helping Caltrans with non-spatial data validation in the use case of supporting them on their transportation asset management systems, like their TAMS project for asset management data governance. We'll talk a little bit about more of that later. Some organizations outside of transportation we have worked with include the state of Nebraska, where we're working with the state on automating their processes for taking data from CAMA or computer-aided mass appraisal systems, validating the incoming data and integrating it, their back end with their GIS. We help organizations such as the state of Michigan and Arizona DOT on their spatial data infrastructures, building automated workflows to ingest the updated data by first validating the data that's coming in, then performing a change detection to find the deltas, and then integrating those changes into their source data sets to maintain proper metadata. Lastly, we're working with organizations to help with facility management. So on the right-hand side, you see Google. So organizations like Google's Real Estate Worldwide Services Group are leveraging One Spatial's tools and services to implement validation of their CAD drawings to assist in easy ingestion into their asset management system, which is IBM Tririga. We've also implemented validation workflows to validate that Tririga database directly. One of our first customers in the US was Arizona DOT, or ADOT. One Spatial started working with ADOT and helping them enhance their data supply chain and assisting them in automating procedures to ensure that the data was going to meet their requirements and help them with developing standard processes like change detection. So ADOT had 14 different counties that were submitting updates to them on over 144,000 miles of roads throughout the state. What ADOT wanted to do was automate that process. So when they receive the data, the first thing that happens now is that they run it through a standardized QA/QC process to make sure it meets the state's requirements. If it does not, then they share back with the original data submission entities where specific issues are identified within their supplied data. Once the data passes ADOT's QA/QC process, it then proceeds into an automated change detection process to determine what is different about the current submittal versus the current road network that exists in the ADOT database. So the system provides what we call proposals on how to deal with those changes, such as, is it an addition? Is it a deletion? Is it a geometric reshape of that current feature? Is it an attribution change? Or is it a variety or conglomeration of those issues? One Spatial's One Integrate system is then utilized to help update the data by a review of those proposals and then acceptance or denial by an ADOT analyst. If denied, the proposal then is submitted for further review to determine whether or not what the system is determined to do is correct. So they actually make that last call before they accept it. Okay. Another transportation customer that joined us a couple years ago is the California Department of Transportation, or Caltrans. So our joint effort with Caltrans is designed to help them validate their asset management and planning system. The current system consists of a variety of different databases, and each one of those houses one part of their asset management system. So, you know, maybe one has bridges in it, and one has pavement in it, and the other has their culverts in it. Caltrans had planned on releasing an RFP to implement a more cohesive system across the board, but first what they wanted to do was understand what is the current status of each one of those systems and databases. How complete is it? How accurate are they? And also, when they perform validations between the different databases, are they in alignment? They needed some help to determine that. So I'm going to pass it over to Kevin, and he can talk a little bit more about this and then jump into some product demonstration. So Kevin, it's yours.
All right, thank you, Brian. Brian, you can hear me, right?
Yes.
Okay, just making sure. All right, thank you, Brian. Yeah, so Brian mentioned that some of the work that we're doing at Caltrans on this on helping them with doing some data validations and so forth for their in lieu of and as part of building out their transportation asset management planning system. So just to give you an idea of like the sheer magnitude of the amount of work that Caltrans does, is one of their programs is called SHOP, which is a fix it first program. I mean, obviously trying to keep their assets up to date, well serviced. Well, this project had a budget of $17.4 billion over 4 years. And so if you can make small little adjustments to the way that you manage your projects, it could have huge savings. So what this system is going to do is it's going to bring in all these different assets and then do project planning across those assets. So if you need to service a set of pavement and it happens to be at an intersection where you have some street lights that need to be updated, you can close the road down at one point, update the pavement, fix the lighting, and then not have to make multiple visits to that particular location. And this is the case for any different assets. There's always different projects that can be strung together in order to gain efficiencies. Now, if you are going to do that type of analysis to determine what assets have needs and need to be actually addressed, you got to get all that information into a system in order to perform those validations, in order to perform those the modeling. As I'm sure you can imagine, trying to integrate these data sources when every one of these asset systems are managed by different departments and using different technology. So there are cases where the payment data is being managed in an LRS-based system. The bridge data may be managed in a GIS-based system. So integrating these become even more challenging. So Caltrans wanted to get, well, one, before we get there, let's see here. So, if you're trying to do one of these integration projects, you can run into some significant hurdles. And one of the stats that I like to show is that 88% of data integration projects either fail or significantly run over budget. And mainly this is due to poor data quality. So Caltrans wanted to get ahead of this. And what they wanted to do was they wanted to implement they wanted to perform some sort of assessment of these systems. So they contracted with Gartner and One Spatial, that's us, to assess these asset systems. This included building an information architecture, but also performing a data quality or building a data quality management plan across all their different core assets. This included validating the individual systems and the cross and how they are related across different assets. So what our role was is we facilitated business rule workshops with the different subject matter experts for all the different asset systems. We built out validation rules in our One Integrate product to perform the validations. And then we put that information into a data quality management plan that can be used by the RFP responders to this implementation of this TAM system in order to understand what kind of challenges they may come about. And then actually beyond that is that this DQMP is actually being used by their data governance group now to actually start implementing policies so that the quality of their entire system is going to be more in line. So with that, I wanted to highlight some of the types of validation checks that we're doing on these cross-asset validations. And to do that, we're going to leverage actually some Michigan data to do so. So we're going to demonstrate running our different One Integrate, One Data Gateway products against some validation checks that are very similar to the stuff that we're doing at Caltrans. So with that, let me first get us all up to speed and understanding what type of data we're going to be looking at. So what you'll see here is a mapping application. This is we're using ArcGIS Pro in this case, but our engine doesn't require any sort of specific technology. You can use whatever GIS application you want to use to run to view the results. So what you'll see here is we have some data in Michigan, and I'm going to just zoom in real quick, and we have some road center lines and we have some culverts. So the first set of validation checks that we're going to run on our data set is to validate our culverts. One, making sure attribution is populated correctly. Do we have a route information? If we know what the shape is circular, then the height and the width of the culvert must be the same. If it's crossing over a road center line, the route information must be the same between these two different data sets. So these are all the types of validation checks we are going to do. So to do that, we are going to validate the culvert data. So I'm going to go flip over to my One Data Gateway product, which is an application that can be hosted either internally in your own network, or it can also be hosted as a cloud-based solution. So if I was wanted to validate my culvert data, I could come in here and I could select which set of data or which project I want to validate against. And you'll notice here there's a lot of different projects we have in this application, but in this case we are going to focus on the Michigan one. So I'm going to go ahead and select that. We're going to start a new submission, and I'm going to grab my data set and I'm going to drag and drop this into the application. Brian was mentioning before the work that we're doing at Arizona, and this is a very similar process where the counties would upload data, and then they want to go through and they want to validate the data to make sure that it's meeting the business needs. So this is just another example where you can collect data from data providers and validate it to make sure it's meeting your business needs. But typically when you're doing this any sort of data roll-up or collecting data from different organizations, they have a tendency to manage their data in their own schemas. It makes sense. They have their own reasons for doing so, their own business systems and so forth. So what we allow them to do in the application is to actually do schema mapping to determine what the source and what the target classes are and the attribution, and it will tell you whether or not everything is mapped correctly. We can also determine which ones we want to select. So we have a predefined mapping, or we could create our own mapping also. Once we save that mapping, we can go ahead and just run the validation checks against the data. So what we're going to do is we're going to first bring in some road data. Now you notice I only uploaded the culvert data. So the road data is existing in an enterprise-based system because we're going to use the culvert data to validate against the road data. So we can pull in data from a variety of different sources. We're not just limited to validating one geo database. We can validate a GIS database. We can validate some sort of non-spatial database. We can bring them together, cross-validate. For this case, we're looking at culvert data and road centerline data. We're going to bring it into our engine, and we're going to validate it against a set of pre-configured validation rules. And I'll get to shortly about how you can configure your own business rules. So it's going to bring those data sets in, and then we're going to run it against two sets of validation checks in this case. The first set of validation checks are what we call our essential geometry checks. They check for typical geometric issues that we find in all GIS data, things like duplicate features, duplicate vertices, kickbacks, spikes, things that just occur when you're doing your GIS editing. Notice that we're getting reporting back about the quality of the data as it's running through. So if I open up this drop down, we could see for each of the rules that we ran against, this is what our conformance levels are. And then we're going to also run it against some culvert data, more culvert specific validation checks, making sure they're not too short, making sure they're crossing over the road center line, making sure that the width and the height are the same, making sure that the roads are crossing over, if the culvert is crossing over a road has the same name, things like that. And we're also getting those conformance percentages in this case too. What you'll also notice is that we brought in a fair amount of data. So we brought in 6,000 road center lines. We brought in about 3,000 culverts, and we ran all these validation checks in probably about a minute and a half. So this just gives you an idea of the scalability of this validation engine. When we validate Caltrans' entire route network of some million records, we were able to validate it against about 16 validation checks, and it took only about 14 hours to run it through that. So that gives you an idea of the scalability. This is why a lot of large national government agencies and even state agencies are using our software. Any way that has lots of data and complex challenges, which could even go all the way down to the county, like in LA County, we can help them with those challenges. So I'm going to go ahead and hit continue. So I can see in the interface itself what my results are from the validation checks. I can download a report to see what the results are. But beyond that, what is more important, what we really want to do is we want to empower the users to be able to go through and correct their data set. Now, to do so, you got to do more than just providing them a report and telling them what's wrong with the data. You got to tell them where the issues are. So what you can do is you can download that report as a shapefile or a file geodatabase, depending on what your system is, and then you can load that into your application in order to zoom to where exactly those issues are. So it really streamlines the process of doing the data cleanup. But beyond that, and we'll get to those results in a second, is that we're also getting a dashboard of all of the quality of the data as data is being submitted over time. So we could see which rules are failing the most, how often data is being submitted. We can look at how the quality of the data is trending over time. All those things we can look for. So if we go back over to my application, let's take a look at some of the issues that we flagged. So we go back out to the state level. I'm going to turn on the data set that I downloaded and brought it into my map, and we could see where all of my issues are. If we zoom to some of those examples, so let's zoom to the duplicate feature issue. I'm going to go ahead and select this feature here. And we could see, yes, we're flagging that there's a duplicate feature. And here I have two culverts, same geometry, same attribution. So we can identify where we had those duplicate geometries. If we have another example here where we have a kickback, notice how it's kicking back on itself, but we're not just telling you that there's an issue with the feature, we're telling you where that issue is occurring. So this can help you drive you to that issue to auto correct it. You can imagine if you had a pipeline or a road center line that extended miles upon miles, if you have this little kink in the network, being able to know where that issue is at is very important when you're trying to do that data cleanup. Here's an example where we have a culvert, and if I look at the attribution, it's of type circular, but we notice that the height and the width are offset. So we not only are we doing spatial validation checks, we're also doing attribution validation checks. If it's a circular culvert, it must have this relationship. And then we can also do validation checks. Looking at, in this case, we're looking at the spatial validation check. We're making sure that the culverts are crossing over a road center line if it's that type of culvert. In this case, these are not, so we're flagging those. And then lastly, here we have an example where we have a culvert crossing over a road, but the naming convention, the naming is not the same. So this one says it's US 10, Waverly Road. It's not a match. We're flagging that. if we look at this culvert here, this one is of US 10, it's crossing over US 10. It's not being flagged. And we can also set tolerances in here. So we're actually ignoring the dash so that we can find those matching. So we can really fine tune these rules to be very specific to the issue that is there. But beyond that, we can do more than just doing validation. We can also do enhancement. We can clean the data up through the engine itself. So for example, if I'm not going to run it live. Well, actually, let's go run it live and then we'll come back. So if we come back over to my One Integrate application, what's going on behind the scenes is it's pulling data in, it's running a series of validation checks, giving you the conformance ratios, but then we can also run what we call cleanup actions. So I'm going to go ahead and just hit play, and it's going to go through these cleanup actions, and it's going to do those cleanups, and then we can rerun the validation checks to see, well, is doing these automated cleanup actually cleaning the data up. So when this finishes, we could bring this cleaned up data set back into the map, and we can look at what the results look like. So if we come over here and go to where we had that duplicate feature, let me turn off the old culvert data set, and I select this particular one here. We're going to see that we now only have one culvert. It removed that duplicate feature. If we come over to where we had that kickback, notice how where we had the kickback originally, we cleaned that up. We also, where we had the culverts that were not crossing over, we base off of a certain tolerance. If there's another culvert that's across of a particular road center line and these have the same route information, we can connect those together. So originally it looked something like this. And then we were able to, build out, connect those features together. So that's looking at one individual asset. But what happens if we start looking at assets across the entire enterprise, more than just comparing culverts to road center line? Maybe we want to look at the bridge data, the pavement data, and the culvert data all on one particular road center line. So if we come over here to my cross asset validation check, you'll see here that we have some bridge data, we have some pavement condition, culvert, and road center line. Now, I'm not going to run this live. I could run it live, but just for the sake of time, I'm just going to show you where the issues are and just show you some of the validation checks that we performed on the data set. So for example, if I come over here and I look at this example here, we are saying that if there's a bridge here, where we have a bridge, we have a route ID, we have an LRS value. We're saying that the road center line must have a value within that LRS range within a certain tolerance. So if I look here, none of these values for this route are within that LRS range. The one that is in the LRS range is located right here. So we could see that this one is, but it's outside that tolerance, which is why we're being flagged. We're using a 20-foot tolerance. This is over 60 feet away. So we could either tweak the tolerance, or maybe the bridge is actually supposed to be located over here and not over here. If we come over here to another example, we're looking at not just the bridge data, but we're comparing the bridge data to the pavement data. And where we should not be reporting pavement condition on a particular where there's a bridge at. So if I select these features here I have my bridge. It's saying that at this LRS value, there should be a bridge. If I look at my pavement condition, I'm reporting pavement at that location. There should be a gap here, and notice that there's not, which is why we're flagging that as a nonconformance. Now, for example, if I come over here to this example here, and we zoom in, we'll notice that there's actually, where there's a bridge, there should be a gap in the pavement reporting. So this is why this one here is not being flagged as a nonconformance. Here's another example where we have a bridge. It's being flagged. If I select this particular bridge here, we could see, yes, we have a bridge. What's interesting is that in this area, there's pavement conditions not located because we're not in that range of values, and neither is a road center line. But if I zoom down, we're going to find actually that there is a gap in the pavement condition right here at this location. And what's happening, and if I look at this particular segment, road segment, that's actually within the LRS range of values. So what's happening is that this bridge should actually be located down here and not all the way up here. So by performing this cross-asset validation checks, we can really see these issues. We can really see where there's inconsistencies between the different data sets. All right, so let's come back over to my slide deck. I know I went through that really quickly. I just wanted to highlight two other quick use cases. Another case is where we're working with DOTs is with validating their crash data, bringing in data sets from multiple different, conflating information over, like the road name information, comparing that, the accident report information to those networks, and then doing cross-validation checks against those data sets. And then lastly, for federal highways, we're doing work with HPMS, so validating, we're updating the validation rules for the new HPMS 9.0 to do more topological type validation checks. And beyond just doing these validation checks for federal highways, we've also worked with a number of DOTs in implementing these HPMS validation checks running on site at their locations. So I really went through that quick, but we had 30 minutes. So we have 3 minutes to go for questions. Brian, did anybody pose any questions for us?
The one that I have was a question about the rules, and can in the rules-based system, are the rules built by One Spatial, or can the customer build their own rules?
Oh, great question. And I mentioned that I was going to show the rule configuration and I didn't get to it. So yes, either you can write your own business rules, or One Spatial can help write rules for you. Typically, we have not typically, we have two trainings. We do an intro training and an advanced training on the product to teach you how to write your own rules. So the idea is to get you self-sufficient so that you can write your own rules. But there are cases where we may either have a set of rules that we've already developed for different DOTs or other, local governments, state governments, that we provide as a set of starter rules. So we have like the HPMS validation checks. We have like road centerline validation checks. We have addressing type validation checks, next generation 911 NENA validation checks. So all those will be like, we can provide to you as a set of starter rules, and then we'll train you on how to write your own, or you can even contract with One Spatial to write all the rules for you, or a subset.
All right.
Thank you, Brian.
And is there any limit to the amount of data that can be ingested into the system?
No. So I surely mentioned the speed and the way that we're processing through the data, but and I didn't really talk about too much of the actual underlying engine. So the reason we can process through this much data and this quantity of data is that it operates on a object-oriented disk cache. So it indexes the individual geometries and the attribution so it can perform quick feature-to-feature transactions. So this enables scalability too. So we work with national government agencies that have extremely large data sets. I know I mentioned Caltrans as an example. Just the other day, we validated some utility data, and we brought in 15 million records, and we validated it in, I think it took about 12 hours to run it through about 20 or 30 validation checks. So just to give you the sheer magnitude of the amount of data that we can process through and validate in a very timely manner.
Okay. All right. I think we're about done. If you could go just to the next slide real quick, I can close it out. So One Spatial, Kevin and I want to thank you for your participation in the presentation and your overall support for the Elevation Geospatial Summer Series. If you're not a member of GISCO or YGEO, you really should be. I mean, it's $2 a month is a pretty small investment to be a part of your state's professional GIS organization. So this is just a suggestion to be a part of that. So if you have any questions, if you want to please reach out directly to myself or Kevin if you have any questions, and we can schedule a follow-up and give you a deeper dive on the technology. So we look forward to working with you in that capacity. Thank you for your time this morning.
Thank you, everybody.